All right, so section 9.6, we are continuing this idea of dealing with still right triangles. That's been our whole focus. This is actually the last section that we'll be covering in chapter 9, okay? Right. Notice the title. It says we are solving right triangles. All right, now before we get to what does that actually mean, let's kind of think about what we have actually done so far with right triangles.
Okay.
We have really only found the missing side lengths of a right triangle, all right? Depending on what they gave you. So what are some different ways to find missing sides of a right triangle?
Well, we've talked about Pythagorean theorem,
okay,
where if you're given two sides, we could find that third side.
Okay, easy.
We've talked about, we just finished talking about trig, the trig functions, which if we had an angle and a side, we could find the other side.
Good.
We've also talked about, like, if we had the right triangle with the altitude drawn to the hypotenuse, that there were some relationships that would help us to find
right
some missing sides because of the similar right triangles.
Okay. There's one that you're missing, is the one that we always want to keep in mind.
Oh, and the special right triangles. Yes. How could I forget about special right triangles?
Yes. Special right triangles, definitely don't forget about those either. Now, most of those cases, you have to have certain things. Now, the good thing about this particular lesson is that you don't have to be given a bunch of different things to solve a right triangle. We're going to continue finding missing sides, but we're also going to learn how to find the acute angles that are missing in a right triangle. Okay?
Oh, okay.
All right? So, here's the deal. It says to solve a right triangle basically means you're going to find the measures of all 6 parts. And what do I mean by 6 parts?
Well, all the sides and all the angles.
So there's 3 angles, 3 sides. All right? Now, that seems like a lot, but I want you to keep in mind you're going to have to be given some things. First of all, you're already given it's a right triangle. So you already
know one angle.
One angle. So that means there's only 5 things that are missing. But notice it says you must know either the following scenarios. All right, so the first scenario here that we have is if I give you 2 side lengths. Okay, so I already have a right triangle, so I have a right angle, and I have 2 side lengths. So really, how many missing pieces do we have?
We really only have 3 missing pieces, 1 side length and 2 angles.
Yeah, so what's missing here, is 1 side, one side, sorry.
1 side.
And 2 angles.
Right.
So 3 pieces that we're really finding. Now, the second scenario is what if I give you, in a right triangle, okay, keep in mind we have that right angle, and I give you 1 side length and 1 acute angle.
Okay, so then I'd be missing 2 sides and 2 angles.
So
really only 1 angle because we already also know the right angle. So really just 2 sides and 1 angle that I would still need to
missing 2
find.
sides and 1 angle. So again, notice how many pieces that we're really finding.
We're really only finding 3 things each time regardless.
Yeah, because they're going to be giving you 3. So when it says solve the right triangle, you're not really finding all 6 parts because you already have 3. What you're missing is the things that we're going to be looking for, okay? So just something to keep in mind. Now, we explored some of these things today about how to find the missing angles, okay, a little bit. We're going to kind of take that a little bit further and kind of where we're going with it, okay?
Okay. All right, so in general, to find the acute angle measures in a right triangle, like I said, we've found all the sides before with different things, but we've never really talked about finding angles. We are going to be talking about using some trig functions, but they're really inverse trig functions today to be able to find those angle measures.
And I remember us kind of exploring this with the calculator today.
Right,
okay?
Exactly.
Okay.
So we said if we know the sine of an angle, so sine of angle A, is going to give us some ratio, then to get the measure of the angle, we need to get rid of the sine part of it. And to undo a sine, that inverse function is an inverse sine.
Okay.
So we're going to take the inverse sine, not sine -1. Yes, that's what it looks like, but it's the inverse sine of the ratio that you're given.
And that ratio could be in fraction form.
Right.
It could be given in decimal form.
It could be. Okay. So the same thing, same idea with all of these. We're saying the cosine of an angle is equal to some ratio. Then to get the measure of the angle, to get the cosine part away from there, I'm going to do the inverse cosine. So the inverse cosine, not cos -1, inverse cosine of that ratio will give us that angle measure. So it's a way to work backwards.
Okay.
Okay.
And so the next one, if I know the tangent ratio is z, then to find the angle of that, where we're referencing, we're going to take the inverse tangent of that ratio of z.
Perfect. Okay, so the whole idea today is we're going to know both parts of the ratio, So we'll be able to write the ratio, or we'll be given the decimal. And with that ratio, I can then go backwards to find that angle measure by doing that inverse trig function.
And don't you find, Ms. Hograby, when we get throwing this in to the mix, a lot of times people get confused of when do I use the inverse versus the regular trig ratios,
yes.
okay? So when you think about when you're finding the angle, you're kind of going backwards. So you're always going to use those inverse trig functions, okay?
Yeah.
So keep that in mind.
In fact, I'm even going to write it down. Inverse trig functions. Find angle measures.
And while she's writing that down, keep in mind the x, y, and z, when you're finding the inverse trig, it's of the ratio, not of the angle. So you're not going to put that angle measure in there because that's what we're trying to find.
Right.
Okay, so keep that in mind. All right, so on the problems that we're going to see is the directions, notice, just say solve the right triangle. So let's make sure we know what that means first.
Okay, so that means we want to solve to find any missing parts, any missing measures. So any missing angles or any missing side lengths.
So how many missing pieces do we have in this picture?
We know we have 3 that we're given, so we're gonna need 3 more.
And more specifically, notice the things that are missing are the 2 acute angles and the missing side, okay? So the directions do say round to the nearest tenth. Even though there's no units, it's saying to round. I've been getting that question a lot. How do I know when to round? Well, it says to round, so let's do it. All right, so where do you want to start? We have 3 things, and I might write off this side. We're finding AC, we're finding angle A, and we're finding angle C.
Okay, let's do them in that order.
Perfect.
That sound good? Okay.
All right.
All right, so first of all, when I talk about AC, that's the hypotenuse of a right triangle. I'm already given 2 sides of a right triangle. I notice that it's not a special right triangle.
I love that you brought that up.
Because that's always the easiest thing. If I have 2 pieces that I can tell that is definitely a special right triangle, for example, if those had both been 8, I'm just going to say 8 radical 2, and I'm not going to do any more work.
Exactly.
But I notice it's not a special right triangle.
Good.
So therefore, I'm going to think Pythagorean theorem.
All right, so if I do that, we always do the hypotenuse squared. So hypotenuse is your AC squared equals the legs squared added together.
Right.
Okay, so we get AC squared equals, what, 164,
164.
right? So when you take the square root,
Now, you actually would get, like, if I simplified that, a 2 radical 41 if we were asked to leave it exact.
Okay.
But we're going to go ahead and say approximately 12.8.
And that's because we're following the directions.
Right.
Imagine that. All right, 12.8, make that known there. And I might just go back and label in the picture. You know, often sometimes we find we need to use it, sometimes we don't. But one thing to keep in mind is you don't want to use a measurement that you found as a rounded answer unless you absolutely have to, okay?
Right.
Because a rounded answer is going to find another rounded answer. It's going to be off, okay? All right, so we got 1 piece down, 2 more to go. Now, where are we going to go next? You said
Okay,
angle A?
let's go for A. Let's just go right down the list. So angle A, I'm looking at that, and I notice that to find an angle, I'm going to be using one of our inverse trig functions. That's kind of the point of today, is just making sure we're comfortable with finding those angle measures. So as I look at that, I notice I have the hypotenuse, but it's not exact.
Okay.
So I'm not going to use the hypotenuse. Okay.
Now, if you did, you could use this.
That's true. I could. But I'm going to go with the 2 pieces that were given to me. And that's what we would really encourage you guys to look for. Because with trig, you can use any trig function.
Yes.
It doesn't have to be one specific one.
Exactly.
So I'm looking at that and I'm thinking I have an opposite and an adjacent. And when I've got an opposite and an adjacent, I know that's going to be a tangent.
And notice, guys, because they give you the 2 legs, the only trig ratio that involves the legs both legs is the tangent.
Right.
Okay.
So
how would I set it up?
I'm going to actually take the inverse tangent.
Okay. So, but if I was setting up before I take the inverse.
Yes. Okay. So we're going to say the tangent of A is equal to the opposite was 10, the adjacent is 8.
Okay. So this is what we've done. We've asked you before what is the tangent ratio in reference to angle A, and this is what you wrote. Okay.
Right.
Now we're going to actually find this angle. So now we're going to take the inverse tangent of that ratio
Of 10/8.
And you can always simplify the ratio. You don't have to, but
Right.
there's really no need to.
5/4.
Right?
Yeah.
And then when that's going to give you what angle A is about.
And it's approximately 51.3. Now, I'm thinking 2 different things here, Mrs. Palermo. I know that I could, if I know that that's 51.3, and then angle B was 90, I could use the triangle sum theorem to be, in fact, even just that corollary that talks more specifically about those two acute angles would equal 90 to find the other one.
Okay.
But what if I made a mistake on my work?
Well, then you're going to make a mistake on angle C.
Right. So I'm thinking, let's go ahead and do the trig function again, the inverse trig function again,
Okay.
to find the other angle. But maybe that's going to be a good check for me to make sure that those two do equal 90 together.
And I'd still use the tangent ratio because you're not wanting to use a measurement we found unless we actually have to. So this time we're finding angle C. So tangent of C, this is the angle. And what would the opposite be this time?
So now I'm going to say 8 over 10 for...
And notice, guys, look at these ratios. Notice how they're reciprocals of each other.
And they should
That should be the case, okay? So the inverse tangent of that ratio, again, you're putting in the ratio when you're finding the angle, and that's going to give you the measure of angle C is about
38.7.
Now, I love that you said use the trig ratios here to do this, find this, because an easy way to check, do these two actually add up to 90 like they should?
Yeah.
Yeah. If you don't do that, guys, you have no way of checking. You're using something you found, and what if you make a mistake? And we're not saying you can't. If you do it that way and don't show work this way, what you would show is just take 90 minus that 51.3. So show us, communicate where you're getting that answer.
Yeah. If we just see an answer with no supporting work, we won't know how you got it.
Exactly. Now, something to kind of keep in mind real quick before we move on to another one, we're going to try one very similar to this, is some things to check. Notice the hypotenuse is the longest of the three sides, so that's good.
That is
the
good.
other thing is notice the two angles. They're obviously different, but do they make sense in relationship to the triangle that we have?
Well, yeah, because I know 38.7 is smaller than 51.3, but the side across from that angle is also smaller than the side that's across from the 51.3.
Exactly. So this is a kind of a logic check. The other thing I'm noticing is notice the two sides that we're given. They're pretty close to one another. So we know it's not an isosceles triangle, but the fact that it's not, we know one's going to be a lower than 45, the other one's going to be bigger than 45. Okay, so those are things to kind of keep in mind. Again, be logical about it. All right?
All right.
Try same directions.
Same directions, new triangle, but now we're given different pieces.
Okay.
Okay, on the last one we were given the two legs. Here we don't know either leg.
Okay.
And on the last one we didn't have any angles. Here I'm giving you an angle. So now what we're given, what three parts do we know?
We have the right angle.
Uh-huh.
We have the hypotenuse. We have an acute angle. So we're trying to find, let's see, we need angle S. We need side ST, length, and side TR.
Right. So we have still three things that we need. Always look to find what are those three things that you need.
Okay.
And you know what? I always think it's a good idea to write those down first.
Yeah.
And then that way you know, okay, I'm going to put my answers right back in this spot because then I know I've got all my pieces that I'm missing.
Perfect.
All right. So let's take a look. Which one do you want to do first?
Well, I think angle S.
I would definitely
And
do that
here's
too.
my thought on it, guys. If you already know this is a right triangle, we know the two acute angles add up to 90. So 20 and angle S should add up to 90. So if I do 90 minus 20, that gives you angle S is 70. And I might even label that in the picture because, you know, who knows. And here's the deal. The fact that I found that angle, it's exact. I'm pretty darn confident that 20 from 90 is 70. So I could technically use angle S to find the remaining two sides if I wanted to.
And I love how you said because it's exact. It's not a rounded decimal like on the last one that we found. All right. Do you want to do ST or TR first?
Let's just do ST first.
Okay. Now, one thing I want you to notice is in our picture, what we are given here is the hypotenuse.
Okay.
So think about what trig functions use the hypotenuse.
Either sine or cosine.
So for sine, we know we did opposite over hypotenuse. And cosine, we did adjacent over the hypotenuse. So just be thinking when you're thinking about what trig functions to use, we know we have the hypotenuse, so we know we're going to be using one of these trig functions.
Okay.
Okay? That's kind of a good starting point every time, just to think, what do we already have and what trig functions use that?
Good. That's a great idea.
All right. Now, let's take a look at what you said you were going to do ST first?
We're going to do ST.
Okay.
And let's just use angle R since it was given to us.
Okay. Sounds good.
So if I'm using in relationship to that angle, ST is opposite of angle R, and we're using the hypotenuse, so that'd be sine. So it'd be sine of angle R, which is 20. I know that degree amount, equals ST over 15.
Awesome. Does that look like a 15? I don't know. Okay. Now, here am I going to be using an inverse trig function?
No, because I already know the angle.
We already know the angle. That's important. Okay, so this is just kind of like what we've done before. We could make a proportion out of it or multiply both sides by 15, however you want to think about it. But we have 15 times the sine of 20 is equal to our ST. So what do you get when you take 15 times the sine of 20?
Well, it's approximately 5.1. And it says in the directions to round to the 10th, so that's what I did.
All right, so I'm going to change this up here to approximately 5.1. Now, I'm going to label it in my picture too. What I want to, now that I've got two sides, use the Pythagorean theorem to find that other missing side.
No.
Why not?
Because 5.1 is not exact.
Right.
And really, there's not, like even the last one we talked about, we had a radical we could use as an answer. There's no radical. So if you wanted to use exact, it would be 15 times sine of 20. And I don't want to type that in my calculator.
Right, exactly.
So it's a lot easier if I use trig again to find TR.
And guys, I know that we've kind of emphasized this a couple times, but do not use a rounded value to get a new answer if you don't have to.
Yeah.
There may be times where you have to. We'll address that in a minute. But
there's ways around it.
So let's take a look now at finding TR.
Now, I'm going to already kind of stress something here to find TR. We're going to, because it's across from the 70-degree angle, I already know it's got to be bigger than 5.1, but it's got to be less than 15. So just make it like a prediction, somewhere between that. All right, so to find TR, we're actually going to have to use a trig ratio. So let's use the...
You want to use a 20 again?
Yes, yeah, let's use the 20 again.
Okay.
So if I was setting this up, let's not put TR equals. Let's put...
Oh, yeah.
That's okay.
I'm like trying to go a step ahead.
Yeah.
We're not there yet.
We're going to use the adjacent to angle R, so it'd be cosine of angle R, which is 20, equals TR over 15.
Right. Again, we're not going to be using an inverse trig function because we know the angle already. We're just finding the side. So again, you could think about multiplying both sides by 15. You could think about cross-multiplying. But 15 times this cosine of 20 should be what our TR is equal to.
And TR is about 14.1, which is less than 15 but greater than 5.1. So that's good. Now, while she's writing that down, guys, notice the kind of work that we're showing. We're showing how we set it up, and then basically we're showing what you're typing in the calculator.
Yeah.
Okay? That's what we expect to see on your end, okay?
You should see really kind of work, not a lot of work necessarily, depending on what the problem is, but work for three things, because there's three things you're finding. Awesome.
All right. It says solve the right triangle. Okay, so now
that we've done this a couple times, guys, we'd encourage you to try this on your own.
Yes, try this first. I'm going to label this triangle. Let's just call it ABC. We'll be generic here. So go ahead and try this on your own, and then check with us. Actually try it on your own, though. Okay, guys. So what are they giving us in this picture?
They're giving us the hypotenuse.
Okay.
And they are also giving us really two angle measures, the right angle and then a 45-degree angle.
Oh my gosh. What does that mean this angle's going to be?
That means that's also going to be 45. We have a special right triangle, folks. Did you catch it? I don't know. I hope so.
I hope so. I hope that you remember this. 45, 45, 90 triangle.
Just means finding those side lengths are going to be so easy. I don't have to do trig here.
And also notice the directions didn't say anything about rounding.
So we want it exact.
And if you use trig on this, you're going to find that it doesn't work so nicely.
It just doesn't give you the exact. It doesn't give you a radical answer.
Okay, so if they're giving you the hypotenuse in a 45, 45, 90, we do know the legs are going to be congruent. Okay, so essentially, we have solved the right triangle so far for angle C. Let me write that off to the side. And now we need to find AB and BC, and we know they're going to be the same.
Right.
Okay, so if I was finding AB...
Well, I know that if I had AB, I would multiply it by a radical 2 to get to that hypotenuse. So I know I'm going to take this 6, this hypotenuse, and divide by a radical 2.
And let's do a quick rationalizing. We've done this a few times so far.
So 6 radical 2 over 2, which simplifies to just be a 3 radical 2.
And that represents
AB and BC. Look at that, we're done.
I love it.
Piece of cake.
Now, what if you did use trig? Okay, if I did use trig, okay, let's say we're finding side AB in relationship to angle A.
Okay.
So this would be the adjacent and the hypotenuse.
So
Which
I'm using
trig ratio?
cosine.
So cosine of 45 equals what? AB over
6.
So essentially you're typing in 6 cosine 45 to get your AB.
Right.
And what does your calculator say?
My calculator says 4.242640687.
Blah, 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 blah.
Yeah.
It's not exact.
It's not exact.
Yes.
Now,
if you type in 3 radical 2 in your calculator,
you
it
get the
gets
exact
the same
thing.
thing. But this doesn't give you exact. So which approach would be best? Knowing that it's a 45, 45, 90 triangle.
Right.
And it's less work, and it gives you the answer that we're looking for. Okay?
Exactly.
So remember that.
And I'll tell you guys that on a test, this would be a great test question. And you will want to use special right triangles for these questions if you can.
Yes.
Because first of all, they're exact. They're going to save you a lot of time. And you guys know that on a test, you don't want to spend a ridiculous amount of time on one problem when you don't have to.
Exactly. And guys, and every year this is something that, and we've been kind of stressing this, but every year, because trig's the last thing we talk about in Chapter 9, it's the more fresh thing. It's the one we want to use all the time. But it's not always the best approach. So just remember, there's all these other options here.
Okay. Last example. It says, during a flight, a hot air balloon is observed by 2 people standing at points A and B. So our little points A and B here, these are just our little guys. My stick guy would not be very pretty, but here's my 2 little guys standing at those 2 points. Looking up at this beautiful, look at that creative artwork, beautiful hot air balloon. And it says the angle of elevation, which we've talked about that before. It's the line of sight that your view would take from kind of based off of the ground level going up to what you're looking at.
So that would mean angle A is 28 degrees.
Right. So yeah, the angle of elevation from point A is 28. Point A is 1.8 miles from the balloon as measured along the ground. So we're measuring along the ground, looking up at the balloon. So really, this measure right here
is 1.8 miles.
Is 1.8.
Okay.
All right. Now, let's go ahead and let's talk for a minute because we're supposed to find 2 different parts. Let's start with just the first thing.
Yeah.
First
kind of
thing they tell
logical
us-
order.
Yep, sounds good. First thing they tell us is that we're going to find the value of H. Okay. Can we do that with the information that we're given?
Well, let's think about what we're given. I see that H forms a right triangle with that 1.8 and that 28 degrees. So technically I have 3 things already, okay? And that's good. It's a right triangle. I have a side and an angle. I can't use the fact that it's a special right triangle because it's not one. Can't use Pythagorean theorem because I only have one side. So I'm going to use trig.
Okay.
So for part A, for trig, let's see. I would be dealing with angle A, and if I'm finding H and I have 1.8, I'm going to use the tangent ratio.
Perfect. So I'm going to say the tangent of A,
which is 28.
Tangent of 28. Sorry, we do have that. Tangent of 28 is equal to what ratio?
H over 1.8 because it's the opposite over hypotenuse. Now notice how she changed that A to 28. If she left it there, that means you would be finding the angle.
Well, and I'd have 2 unknowns, which we can't have that.
Yeah. So, okay, so we're going to solve that. Put that over, maybe over 1 or whatever, how you want to do that. So it'd be 1.8 times the tangent of 28, which is, okay, the calculator gives about 0.95, blah, 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 blah. So let's say 1.96.
Okay.
We're rounding
because it was
9.57.
All right, perfect.
And this is miles. So just under a mile, basically.
Yeah, and that is talking about this height. So it's just under a mile.
So about 0.96.
To get from the ground level all the way up to the hot air balloon. So it's pretty high up.
Okay.
Okay.
And we can round here because there's units, guys.
Right.
Okay.
Now, let's talk about part B.
All right, part B. let's see, it says point B is 2.8 miles from point A. So that means those people are 2.8 miles apart. Well, that already knows then that distance that's remaining from B to the balloon is going to be 1 mile.
Okay.
Okay, it says find the angle of elevation of point B. So we're basically finding the angle that we're looking up at the balloon. So that's the angle we're finding right there.
All right, so now here at point A, we were given the angle measure. Here we're finding the angle measure. So hopefully we're thinking something that we learned.
Well, we're going to, if we're finding an angle, unless they're giving you the other acute angle in that triangle, which they're not, and it's another right triangle, so I'm seeing that, then I would have to use the inverse trig functions.
Perfect.
Now, to know which inverse trig function, let's talk about which trig function we're dealing with the ratio. Well, I'm basically, okay, I have the 1 mile.
Which I'm glad that you found that because you knew you needed that part of the right triangle.
And here's the deal. The 0.96 is what we already found in the last part, so we're going to have to use it this time.
This time we do because, and it is a rounded answer, and we try to not use those rounded answers if at all possible. But here's the thing, guys. We need 3 things to be able to find missing parts of a right triangle. We know we've got a right angle, and we know the 1 mile, but that's all we have. So here the 0.96 is the next thing that we do have. Now, one thing I want to emphasize is you actually should still have that huge long decimal in your calculator. We could leave that big long decimal in our calculator and not round it.
And talk about how to type it in, right?
And then that would, that would allow us to be able to have a more exact answer.
Okay, let's just set it up.
Okay.
Let's say the tangent of B is equal to, now, here's the deal. If you for some reason can't figure out how to leave it in the calculator, all right, we're going to kind of stress how to do that in just a minute, and we'll talk about it in class if you need help with it. This is what my rule of thumb. I would say if you do use a rounded answer and you have to retype it, I always say use more decimal places, and I always say 4. So let's type this write down 0.9571 over 1. Now, if you're using your calculator, all right, so you have that in your calculator. Well, I did. Let me get it back in there. When I have that in your calculator, we're wanting to take the inverse tangent to find that angle, right? Of basically anything over 1 is just that anything. So it's that 0.9571, blah, blah, blah. Okay, so I'm going to take the second button, the tan, so it's going to say inverse tangent. And then I'm going to hit the second button again, and it's in the negative sign, down kind of by the equal sign. Okay? You're writing second and then writing the shortcut. So second, the negative. That's what it looks like. And in the parentheses, it's going to say A and S. They're saying take the answer from the last thing I did and put it in for that. Replace that. So we're taking the inverse tangent of that ratio and then push enter. And it's going to give you the measure of angle B is approximately 43.7. And then it keeps going. But let's just round to the 10th, 7 degrees.
All right. And that was talking about this angle
right
here.
There. And again, guys, if you typed in the inverse tangent and typed in 0.9571, guess what? It's still going to get you 43.7 degrees.
And that's nice because they've only asked us to round to the 10th on a lot of these problems. Where usually we'll have you round to like the 100th place, give us a couple decimal places to make it a little bit more precise.
But if I had round to the 10th on my height, it would have been 1, and then I would have actually ended up with a 45-degree angle, which would not be even close to 43.7. So you don't want to round so much. That's why I say if you do have to round and you're using a rounded answer, do 4 decimal places. The more actual exact you can get, the better, okay? Right. Now, before we move on, one thing that I kind of brought up was that 45, you would have gotten that. Notice the sides 9.96 and 1 are really close to each other.
Yeah, really close. And so, almost
a
45, 90.
And so notice, so that's why 43.7 degrees is pretty close to 45. It's less than that because 0.96 is less than the other side.
Yeah.
Okay?